Hey there, this is Aman here. I think this has been a while since the last time I showed you guys the demo video on how to build a simple speech recognition bot using Python. So today I'm going to share with you how you can use Saturn Cloud, alright, to spin off their Dask cluster and how to use that to run your Jupyter Notebook on the cloud in minutes, alright. So I think right now, I assume that you're already in my article reading my introduction of Dask on how to use Dask in your own data sets. So here, if this is the first time you come here, you haven't used Saturn Cloud before, you can go to this link here just to register to get the free trial, right? So here, you're gonna fill up the simple form here, and after that, you get the access to their cloud server, okay? So here, once you have already logged in here in your own account, in the Saturn Cloud account, you will need to create your own Jupyter Notebook. Okay, before you can spin off any Dask cluster, you need to have at least one project. So the project here could be a Jupyter Lab, could be a Jupyter Notebook, up to you, right? So here, if this is the first time you want to create a Jupyter Notebook, you can just come here and define your name of your Jupyter. The disk space allocated. So right now, I think Saturn Cloud is offering up to 1 terabyte. It's a lot. It's huge. And the size of the RAM, let's see, I think minimum 4 gig RAM, but you can use it up to 512 gig. So it is a lot. It's huge. Also, the auto shut off duration here, it depends on how often you want this Jupyter to shut off depending on your uptime, right? So if you just leave it alone there for like 10 minutes, it will just shut off automatically. The image here, by default, Saturn Cloud will give you a default image here, but assume that you have a team, you want to, build your own image, you want to define your own image environment. So you can here put on your Python environment here, all the versions up here to create your own customized image, right? But here I just use back the default image given by Saturn Cloud. Alright, cool. So once you have done everything here, you can just click create. So typically this should take about a few minutes for them to spin off a cluster to allocate the resources for you. Alright, so now assume that you have already created a Jupyter project, right? So either you can go to Jupyter Lab or Jupyter Notebook, but here we're gonna just use the Jupyter Notebook for simplicity purpose, right? But now we still haven't created the Dask cluster yet, because at the end of the day, the purpose of this video is to show you how you can run your analytics, your data cleaning on Dask cluster. So here we need to come to this place called Dask, right? And now, once you have come here, if this is the first time you come here, this will be empty. So you gotta create a Dask cluster for your project. Okay? So assuming that you have already created a Dask cluster, you can just follow the default mode, don't need to change anything, and just click create. And this will typically take about a few minutes for your cluster to be ready. And then after a few minutes, your clusters will be shown here, and you can just click your scheduler URL. Alright, so this will be like your ID, your cluster ID for you to spin off, for you to use your cluster, the allocated cluster for you. Right, so the dashboard here is basically a monitoring dashboard for you to monitor all the tasks allocated for you, etc. So here, once you click here, if you have run some tasks, you'll see that all the tasks allocated in different partitions at different time. So here you can clearly see how your tasks are being allocated in different spaces. Okay, so sure, now we have already created the Dask cluster. The third thing that we need to do is to go back to the Jupyter tab here. Okay, and now we want to open up our Jupyter Notebook. So here, since I've already created my own Jupyter project, I just click to this Jupyter Notebook here, and this will bring me to the home page. Right, the home page, and I'll just come to this project directory, and boom, I'll just create all the notebooks and upload all the data set that I need. So for you, you can upload your own data set or upload your own Jupyter Notebook here and run on the cloud at scale, which is cool, right? But since this is the first time we are here, so here we're just gonna create a new notebook here, which is this EDA for us to analyze the e-commerce data. And since this is a demo video, I'm gonna show you some of the predefined code, right, to show you how you can exactly run the code, the Python code on the Dask cluster. So once I open this notebook here, alright, so now we have the notebook ready. Now here, before you can use the cluster, you need to call the client and define your cluster, right? So here you're gonna put in your scheduler URL, which you can find it on your Dask tab. So you come back here on your dashboard, go to this scheduler URL and copy this line here, admin all the way until here, right? And you copy this and paste it over here, which is your scheduler URL, and this will spin off your cluster immediately and you can use it right after. Okay, so here I am allocated to, let's say I run this, I'm allocated to 10 workers with 10 CPU cores, about quite a big memory because of the specification that I selected earlier. Alright, so here you can just do whatever you want. It's basically the same thing that you usually do in your own Jupyter Notebook. So here nothing changed, we just follow back what we are used to do. So we import all the Python libraries here and we just read the Dask data frame, right, to a variable here. So here I'm getting the data from the Amazon S3. Of course, you can also upload your data set to your directory here and you can call it as well. So it's up to you. You can call it from Amazon S3, call it from your local directory, from your directory here, or call it from other HDFS files, whatever things, right, directory that you want to call here. So here I specify the block size to be 32 megabytes. So at the end of the day, it's up to you for you to define how big your partition that you want. So if you have read my article earlier, like how I define the partitions here, you can define the partition to be bigger, to be smaller. So it's definitely up to you to decide how big the partition that you want. So maybe one CSV file you want it to be one partition, that's up to you. So here, since I just loaded one CSV file, I purposely split it into 2 different partitions to show you how exactly this partition works on the backend, right? So here we already defined this data frame, Dask data frame. If you just come and run this df, typically on the pandas data frame, if you just run the df, it will show us all the data sets in data frame, right? But here in Dask data frame is slightly different. It will still show you the data frame structure in Dask, but it will show you just the column name, the partition number, 2 partitions here, and how many tasks that you can run concurrently. Okay, here you also can see that in fact your data set is not loaded in memory yet. Okay, they just try to infer the data type in your data frame. Here you can see that each of the columns data type that I have, object, integer, float, etc. That's why Dask can run so efficiently and so fast, because they haven't done anything unless you execute the method, which is the compute method, which I'll explain later on. So here, finally, if you just click this dot head, it will show you the top 5 as usual, the data set for top 5 rows of your data sets. But since we have already understood that Dask data frame, most of their interfaces, they provide lazy results, which means it is essentially a graph. If you are familiar with TensorFlow, all this, essentially they are building a computational graph and they don't execute unless you call a method to trigger the execution, right? So here in Dask data frame, it hasn't really loaded any memory in yet. Okay, it just shows you the object, data type, etc. So here, even if I just want to calculate the average value of the unit price here, if I just dot mean, which is what we typically do in our pandas data frame, it will just show us a series with without any computation. So this is not what we want, right? So here, if you want to get the true result, you need to what? You need to run this df.unitprice.min.compute. So what you need to add is just the compute method. That's it. So this will trigger the whole execution, the whole graph, the whole computational workflow operation that you defined earlier or predefined here, which is the .min. And this is how we really execute an operation in general using Dask DataFrame. Even if you want to find out the shape here of the data frame, you need to use a compute, etc. Value counts. So you can see all the things are essentially quite similar. They're essentially very similar to what we used to do using Pandas DataFrame, which is cool, right? Because this is what we want. We don't need to learn an entirely new different syntax or language just to run things in parallel, which is very effective and time saving for data scientists, right? So here, again, you can see each of the partitions here. Like we already know, each of the partition is essentially a Pandas data frame. Okay, so imagine right now our Dask data frame has two partitions. Each of the partitions here is one Pandas data frame. So if you choose one of the partitions here and make the compute method here, you are essentially showing this particular partition. And this is in the Pandas data frame format, which is cool because maybe you want to do some operation or transformation for this partition. We can just load it to a new variable and we can do whatever things that we want, like what we used to do in Pandas data frame, right? Also, you can rename the column names like what we do on our Pandas data frame. All the things here. You can do data cleaning, like all the previous code that you saw on the article, the things that I just shared with you guys. Data cleaning and some of the missing values calculation, and even you can change the date time, right? This is the syntax here, the method used here is exactly the same as how we use in Pandas data frame. Or maybe sometimes you want to find the data set based on certain conditions, so you can do the same thing as well. So this is cool. And in general, overall, this is how Dask DataFrame works on Saturn Cloud. Alright, so the steps here are pretty simple, which I'm quite surprised the first time when I tried to use this platform. I think there are some of the few main steps here that you need to take note. Just that the first time when you go to this platform, what you need to do is just to create a new project, a new Jupyter project, and then you just go to spin off your Dask cluster because you want to use their own features. And right now they are offering some of the free trial, okay, for new people like you and me to try out their platform and Jupyter. I think it's a good way for you to get used to the cloud computing, because I really believe that this is the future of how we do data analytics in terms of performance and scalability purpose. Okay, because data volume is getting bigger and bigger. We can't really do the analytics in our computer anymore. Alright, so I hope this is helpful to you, and I hope you can give it a try, and just let me know if you have any feedback or any thought on this platform in the comment below. So I will see you on the other side.